Hi, I'm Jeff from MORryde. Today we're going to be going over how to properly measure driveline angles to help us diagnose your driveline vibration. What you're going to need is a digital angle reader that has a precision of 0.1 degrees. This is very critical, so please make sure you get one of these. We prefer the Craftsman 7-inch. It can get you in certain areas that are tricky with larger ones, but it also is relatively accurate and not too expensive. You're also going to need a simple tape measure. When measuring driveline angles, it's imperative that the weight of the unit is on the wheels. We will normally just drive in a unit and get on our creepers and measure it from underneath. That's perfectly fine. For the sake of the video, we drove it onto a 4-post lift where the weight is again supported by the wheels. Another option that will work is to use the 4 individual mobile pads if you have those. The one thing that we cannot let you use is a 2-post lift, as the rear tires are not supported. Thus that changes the differential and the rear shaft. When you go to zero your angle meter on the frame, make sure that whatever plane you're looking at it from, you're going to be able to access on every driveline measurement that you have. You can't flip it around and take measurements because they will be invalid. They'll be offset from the zero. They are only accurate in the view that you looked at when you zeroed it. When pulling a unit in, drive it in or put it in neutral and push it in so that the differential's flange is directly vertical. This will help you to get an accurate measurement on that angle. Okay, on an E-Series chassis there's a trick to measure the transmission angle that's a little easier than on most, so we'll show you that. What you're going to do is come up here on the transmission. There's usually an etch 22, 23, something like that. You want to avoid that raised layer, but just set your angle reader right on that lip. Make sure you're not on the embossed angles and let it hold steady. I got 5.3. Put it back up, test it again, and I'm still getting 5.3. So the transmission on this one is at 5.3. Okay, we're going to measure Driveshaft 1. I'm going to stick the angle reader up to the bottom of the tube. Make sure it's in line with the tube and coming straight down. There's a little groove to help make sure that you're not going crooked. Let it sit there and rest. Make sure it comes to a rest before recording your measurement. I'm getting 4.1 degrees. I want to take it off and put it back up in the same spot relatively and measure again. Again, checking to make sure you're in that groove and verify that you're getting the same measurement. We got 4.1 degrees again, so we're good. Then we're going to measure center of U-joint to center of U-joint, which is 32 inches on this shaft. We're going to record those two numbers, 4.1 degrees and 32 inches. Okay, we're going to do Driveshaft 2 now. Stick it up in the center there. Get it centered up, lined up. Feel that groove and let it hold steady. Got 3.6 degrees. I'm going to take it off. Make sure you're smooth. Retest. I got 3.6 degrees again, so we're good. Measure our center of U-joint to center of U-joint on the correct tube, and I get 34 inches. So 3.6 degrees and 34 inches on the second drive shaft. Okay, we're going to do Driveshaft 3 now. We're going to stick it up. Again, a reminder not to turn this around. It'll change your angle readers. I'm getting 2.7 degrees. Stick it back up. Check it out. And it settled at 2.7 degrees again. So 2.7 degrees. And center of U-joint to center of U-joint is 47 inches. As noted before, we drove in the unit so that the flange yoke is vertical and we can get our angle reader in a vertical spot to accurately measure the transmission output yoke. So in this case, I'm getting 86.4. I want to come around and make sure that I got it vertical. Stay at 86.4. I'll take it off, put it back on, repeat the measurement just to make sure. And I got the same measurement again, so 86.4. So what we'll want to do is 90 degrees minus 86.4 is the angle of the differential. So that would be 3.6 degrees.